Okay, in this lesson we're going to take a look at how do we use the information we know about significant digits and accuracy as we calculate with different numbers. So we're going to focus in on dealing with multiplying and dividing. This is really important that you connect that this is multiplying and dividing that we're dealing with different numbers, and we're focusing on accuracy, or the number of significant digits. Okay, this isn't the best example, but it gives you an idea of just multiplying with some numbers. Suppose that you want to find the area of a rectangular plot of ground that measures 206 meters by 84 meters. To find the area, you're going to need to multiply these together, and you end up with this number here, 17,304 meters squared. The outcome shows 5 significant digits, while the original measures show 3 and 2 significant digits. And so our rules of accuracy tell us that to be consistent when multiplying and dividing measurements, the product or quotient, whether you're multiplying or dividing, can be no more accurate than the least accurate measurement. In other words, the one with the fewest significant digits. Another way to put that, in this particular example, is you need to round the 17,304 meters squared to 17,000 meters squared, because our answer can only have 2 significant digits, because 84 here only had 2 significant digits. Our answer can have no more significant digits than either of the components that make up the problem. So the deal is you need to round the result to the same number of significant digits as the measurement that has the least number of significant digits. That is, round the result to the same accuracy as the least accurate measure. That was 4 different sentences basically saying the same thing. Whichever one resonates with you, go with it. But basically, you look at your answer and you're going to have to count in from the left the number of significant digits that are in your least accurate number. So we're going to practice this so you kind of get into the routine. And before you do this, you might want to go back over and review the rules for finding significant digits, identifying basically whether or not the 0 is significant. That might be helpful. We're going to go on and do about 6 problems here just to make sure we've got this down. Okay, our first problem here, we've got 8.1, or 8 1/10 inch times 2 7/10 inch. Basically what I'm going to encourage you to do is write the number of significant digits above each one. In each case, both of these are 2 significant digits, so we know our final answer can have no more than 2 significant digits. If you've written that there, that's going to help you stay on track. Then you can go to your calculator and just punch that in, and you should get 21.87. Now, the deal is our answer can have no more than 2 significant digits, so that's where I have to count in from the left. And I realize that sometimes when we're dealing with rounding and numbers, most students are looking at the right end of the number. And with these rules, you're counting in from the left to identify where you're going to round to. So in this case, we're rounding 2 digits in from the left. That would be right here. I look immediately to the right. That number is greater than 5, so I come back here and I'm going to round this to 22. Basically, this is going to be inches squared. I'm not very concerned about the unit on here. I just really want you to get the right number of digits. Okay, in this next problem, we have 75 miles per hour times 14.2 hours. We've got 2 significant digits here, 3 significant digits here. Our answer can only have 2 significant digits. So when we punch this into the calculator, we're going to see that we have 1,065 miles per hour, whatever it's going to be. But our answer, for the purposes of using the rules of accuracy, I can only have 2 significant digits, so I'm going to have to count in 2 places. This is my second place value in. Look immediately to the right. That is greater than 5, so I come back here and round this to 1,100. Over here we've got 3 significant digits, and we've got 2 significant digits. Our answer, again, this isn't a very good example because all of them are 2 significant digits. But when we punch this into the calculator, you get 21.716. This is what I want you to see, is that your calculator can really explode with all these extra digits. Even though you only started with 3 digits here and 2 digits here, we all of a sudden have an outcome of 5 digits in our answer. So you kind of have to have rules of some sort. So we are going to round to two significant digits, counting in. We're going to look at this. We're 2 digits in. We look immediately to the right. This is going to be greater than, or is greater than 5, so we come back here and round this to 22. And this would be centimeters squared. Okay, so things really change, could really change in terms of number of significant digits, but it really goes haywire when you get into division. I want to go back to the numbers in this problem. Here we had a 3 significant digits multiplied by 2 significant digits, and we got 5 digits. I want to see what happens. I want you to see what happens when you divide. Let's take those same numbers. We've got 206, and we're going to divide by 84. I'm just going to divide them so you can see what happens with division. And so with divisions, I mean, this just rounded off because my display can only show 10 characters, I believe. So things really blew up when we divide. We get lots of extra digits. So again, that just kind of brings it to mind as to why we need to do this. Okay, so looking at this next problem, we've got 3 significant digits here. We need to identify, is that 0 significant? It's to the right of a decimal. That means it could have been rounded to that place value. It might have been 8.98. Would have rounded to this. So that 0 is significant. So we have 2 that we're going to be rounding this to. When we plug this into the calculator, 728 times 9, we end up with 6,552. Our rules of accuracy say that we need to round to 2 significant digits, counting in from the left. This 5 is the second place in. We look immediately to the right, that's 5 or greater, so we're going to come back and round this to 6,600. So now our final answer has 2 significant digits, the same number of accuracy, same level of accuracy that we have here. Here we have 23 divided by 7.1. Again, both of these are 2 significant digits, but when we plug this into the calculator with the division, that often just really explodes with all these digits that we don't need. I could go on and on, but we don't want to. This is only, we need to round this to 2 significant digits. We'll look 2 places in from the left. That lands us here in the 10th place. Go immediately to the right. Means we're going to come back here and drop this down to 3.2 significant digits. Okay, here we've got 3 significant digits, 2 significant digits. When we carry out the division here, we're going to have 1.496158. Don't really care about all those extra digits because we have to round this to 2 place values. Counting 2 places in, we land in the tenths. Go immediately to the right. That is greater, so we're going to come back here and bounce that up to 1.5. So we can see here, you know, we rounded to the tenths, This actually rounded to the hundreds. Back here we had an example where things rounded to the hundreds, whole number, whole number. A lot of times students will say, well, tell me, do I round to the tenths? Do I round to the thousandths? What do I round to? It depends on the accuracy of your problem. So you have to use the rules of accuracy when you are multiplying. This only applies when you are multiplying and dividing. We have different rules when it comes to adding and subtracting.